And we're going to be programming our pulse width modulation so that you press the yellow button, it runs this direction to this switch. And we press the green button, it runs the other direction and stops at this switch. All using pulse width modulation to a stepper drive, and we're giving it a direction from a discrete output. Please take a moment to like this video and subscribe to our channel. We put out at least one automation video a week. And any questions that you have, feel free to put them in the comments. This video is due to a viewer's question. If we look in the Micro820 Programmable Controllers Manual, then we can see that it does have PWM support on the 2080 LC20 20QBB and 2080 LC20 20QBBR. Both of them have support for one output. And if we use our find and we go down a few more, then all right, we're going to see here the LC20 QBB and the one with the R at the end of it. Discrete output number 6 is a pulse width modulation output. So let's add a few wires between our trainer and the motion control trainer. Quick review of the wiring that we've done in previous videos on the motion control trainer is we have our stepper motors A+, A-, B+, and B- going to our stepper driver A+, A-, B+, and B-. Then we have a wire from the plus of our stepper motor going to the top of both of our limit switches. Then we have a jumper from the bottom of both of those limit switches, and it's going to the EN+. Then we have a wire from the ground of our stepper driver going to the EN-. Our outputs on our Micro820 are going to be sourcing, so that means that we're going to be connecting them to the pulse plus and the direction plus. So I'm just going to connect a wire to both of those and lay them over here out of the way. We'll connect those to the PLC in just a second. And we're also going to connect all three of these sensors. So I'm going to connect a wire to the out of each of these sensors. And we'll lay those over to go to the PLC. All right, now we need to power our sensor and get the 0 volt to it. So we had a 0 volt on the EN-. So we're going to connect there, and then we're going to go to the 0 volt of this sensor, and then we'll connect to the 0 volt of that sensor, and go to the next sensor, and we'll go to the 0 volt of that sensor, and connect to the final one. And same with the plus. So we have plus right now going from our stepper driver up to our 2 limit switches. So I'm going to go from a limit switch to the V plus of one sensor, and out of the V plus of that sensor to the V plus of the next sensor, and finally that V plus to this V plus. Then since our outputs are sourcing, we're going to connect the pulse minus and the direction minus to the minus of our power supply, which is also what enable minus is. We're just going to take a wire from it and connect it to direction minus, and from direction minus to pulse minus. Our PLC trainer is wired per the Getting Started guide, and you can find all of our wiring diagrams for our trainers in the standard drawings section. If we look at the TRN BAS M820 AOI, then we have button 1 wired to input 4, button 2 to input 5, button 3 to input 6, button 4 to input 7, and switch 1 to input 8. So I'm going to wire those 3 proc switches to input 9, 10, and 11. And then on our output side, here is output 6 that we need to wire that pulse to. And I'm going to wire output 5 to the direction since it's right beside of it. When you're done, you'll have connections to COM0, which goes to the 0 of our 24 volt power supply. Input 4 is going to be the green button. Input 5 is going to be the yellow button. Input 6 is going to be the red button. Input 7 is going to be the blue button. Input 8 is going to be switch 1. Then input 9 is going to be our left proc sensor. Input 10 is going to be our middle proc sensor. And input 11 is going to be our right proc sensor. Then on our output side, our plus COM0 will be plus 24 volt, Output 0 is our green light. Output 1 is our yellow light. Output 2 is our red light. Output 3 is our blue light. Minus COM0 goes to a 0 volt of our power supply. Plus COM1 goes to the plus 24 volt of our power supply. Output 5 is going to be our direction plus. Output 6 is going to be our pulse plus. Then minus CM1 will go to the 0 volt of our power supply. Then let's create a new program, and I will just call this our PWM. And let's go into controllers, Micro820, and find the 2080 LC20 20 QBB. Select it and add to project. And then before we forget it, let's go ahead and set our Ethernet configuration. And I'm going to have mine at 192.168.114. Now our default trainer address is 192.168.110. So if you've been using that, just stick with that. But I already have 10 set up for another video right now. Then let's right click our main task, add ladder diagram. Go ahead and open it up. And let's bring down an instruction block and type PWM. That's going to bring up that enable PWM output. So we've got some variables that we need to create. We're going to need to create an on variable, which will be a Boolean. We're going to need to create this frequency, which is how fast we want to pulse it. And then we're going to need to create this duty cycle, which is how much time should it spend on compared to how much it should spend off. And actually, we don't need to create these. So first, let's create these three right here. So this was a Boolean. Double click. And we're going to create a PWM on. And that will be a Boolean tag. And then our frequency is going to be an unsigned double integer. So open this. And we'll call this our PWM freak. And that will be an unsigned double integer. Then we have our duty cycle, which is an unsigned integer. So PWM duty cycle, and that'll be an unsigned integer. Now let's highlight the instruction and hit F1. That way we can see how we need to deal with these other three parameters here. So we scroll down here. And channel type is going to be 0 because we're using the embedded Micro820 output 6. And then channel slot is going to be 0 because it's embedded. And then channel number is going to be 0 because there's only one pulse width modulation on this. So these we can just type 0 into them. So our channel type, our channel slot, and our channel number will be 0. And now let's go ahead and create this status over here too, just in case we end up with an error or something. So status is an unsigned integer. So we'll let's create PWM status as an unsigned integer. And this would be enough to get us some pulses moving. But let's go ahead and get a little bit of control of this thing. Let's add a rung. And we're going to use an examine on. And go to our I/O. And input number 4 is our green button. So green button. In fact, let's label all of these while we're here. Input 4 is our green button. Input 5 is our yellow button. Input 6 is our red button. Input 7 is our blue button. Input 8 is going to be switch 1. Input 9 is going to be our left prox. Input 10 is going to be our middle prox. And input 11 is going to be our right prox. And then right after that, we're going to need some outputs. So let's go ahead and label those as well. So 0 is our green light. 1 is our yellow light. 2 is our red light. 3 is our blue light. Then 4 is a spare. 5 is going to be our direction. And then 6 is our pulses. Okay, but originally we were looking for the green button. So select the green button. And then if the green button is on, then we are going to use a direct coil output energize, and we are going to energize our PWM on. And that is what we're using to turn on our pulse width modulation. Now let's go ahead and add a branch around that though, because we also want to go the other direction. So bring a branch down and another examine on. And this time we are going to look at our yellow button. So either of these we're going to turn on our pulse width modulation. Then let's bring down another rung and an examine on. And again we're going to look at this yellow button. And then bring down an output energize. And this time we're going to turn on our reverse. Or I'm sorry, our direction. This means that we're going to get pulses whether we hit the green button or the yellow button. But when we press the yellow button, we're also going to reverse direction. So let's download this and see what it does. And if you need any help downloading your program, or if I went too fast through creating a program or some of those basic instructions, look down in the description. We have a whole lesson series on the Micro820 PLC and Connected Components Workbench. Okay, before we can use this, we need to put some values into our PWM frequency and the duty cycle. And honestly, the duty cycle is a little confusing the way they have it in the manual, and I didn't go real deep into this. But here's our high-speed output right here. It has a maximum turn-on time of 0.2 microseconds and a maximum turn-off time of 2.5 microseconds. So it takes it 5 times longer to de-energize than it does to energize. Now, when I think about trying to balance out the duty cycle, I just kind of think 1 divided by 6, which is 15, 16, 17%. But they kind of go into some more details here about it, and honestly, I got lost in this. And really, this video is at request of somebody. I don't actually have an application to do it. So I would definitely look in this manual around page 1, starting at 135. That's going to go through some details about what the duty cycle needs to be. And it's not a big deal when you're running at these lower frequencies. But what they're saying is as you hit these higher numbers, you're going to start having error. And I really am just going to leave it at that because, yeah, I'm not sure. So what I'm going to do is I'm going to put this duty cycle at 15. And that means that it will spend 15% of its time on and the other 85% of its time off. Since it takes it longer to turn off, that should help that out. And then we need a frequency, and let's just throw a value of 100 in and see what it does. So I'm going to press the green button. Okay, and we do have some movement. Let me get a close-up of that. Okay, here's a good reference point. That's coupling right there. I'll press the green button. It's going counterclockwise. I press the yellow button. It's going clockwise. And while we don't have feedback, we do know how many pulses we need to send it, at least roughly, to get a speed. So 1,000 pulses is 1 revolution of the shaft. So if we put 1,000 in, it should take roughly 1 second per revolution. So I'm going to change our pulse width frequency to 1,000. Okay, and we can use those set screws as a reference. 1,000, that's pretty close. Now let's integrate these switches in here, because I press the green button, it runs backwards. It runs forward with the yellow button. So let's make it that when we press the yellow button, it runs without holding this until it reaches this. And also let's put the stop button in. And same with this direction, we'll do the green button. So we'll make a start stop, and we'll have these sensors as additional measures. So let's go back offline, and right here's where we were doing it. So what we're gonna do is we're gonna bring another rung down, and we are going to look, actually this green button right here. So if our green button is pressed, then we are gonna output run left. All right, and then as long as that tag is energized, so we'll bring down and examine on, and we are going to look at run left. And we're going to continue running unless, let's see, and our stop on this one is wired normally open. So we're going to go look for a 0 on our stop button, which is our red button. And then we're also going to be looking for a 0 on our sensor. And that is input number 9. So if we hit our green button, then we're going to energize our run left, and it's going to stay energized as long as our red button isn't pressed or our left prox isn't pressed. So let's just highlight that and copy, paste. And same thing, except for we're going to want our yellow button, and this time we are going to use run right. All right, and now instead of energizing our PWM with the green button or the yellow button, we're going to use the run left and run right. So run left, and this one will change to run right. And then in addition, we were using the yellow button for our direction. We're going to change it to run right. All right, that should get us, oh, wait a second, I got a typo here. I got a classic copy and paste error. We got run left, run left. This should be run right, run right. So in my rung 3, I need to change that to run right. Also change the left prox of rung 3 to input number 11, which is our right prox. And actually, I'm going to change this. I'm going to change it to the middle prox because there's no need in us going all the way to that far prox there, just for this demonstration. So I'm going to use a middle prox. Also, we should put some initial values in our frequency and duty cycle because each time we download, we're going to have to re-enter it. I'm going to put initial value on the frequency of 2000, which should be 2 revolutions per second. And the duty cycle, I'm going to keep it 15 for 15% on and 85% off. So let's download that. Okay, if we've done this right, then I should be able to press the green button. And yeah, it's running towards that switch. All right, and it stops on it. Now I should be able to press the yellow button and one get off that switch, but it should continue going to the right. Now it should be stopping about now. There we go. So there's some basic control. So I hope this video has been helpful. Please hit that like button and subscribe to our channel. We put out at least one automation video a week. Till next time. Hey, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!